What's up, young mathematicians? Thank you for stopping here at Tau 2 Pi. I am Caesar the Tutor, and today we are going to be talking about composition of functions. What is composition of functions? So far we talked about inputs and outputs given to a function. You give a function an input, and the function returns an output. And if the input is valid, the output will also be valid. We could actually put anything in there, and as long as we can evaluate it, we're going to get a valid output. So if they give you a function, if they give you a number, if they give you another letter, or if they give you a happy face, the only thing you have to do is take it and plug it in and express it, simplify it if you can, and you're done. In this video, we're going to see how to compose functions symbolically. We're not going to evaluate them. We're not going to plug in values. We will also be talking about the domain of the functions. And usually we don't talk about the domain and the range at the same time because the domain is a lot easier to figure out than the range. In the next video, what we'll do is we will do examples with numerical values, and then you will be able to see how the domain is affected and how the range is affected depending on those values. So without further ado, let's get started. To begin, let's take a look at the notation. Parentheses, f, small circle g, parentheses of x equals f of g of x. That right there is small o, small circle, sometimes read as FOG, sometimes read as fog. I read it as f of g because it reminds me of what I'm doing. F of x means plug in an x into f. F of g of x means plug in an x into g and then plug in that g into f. And so let's remind ourselves of what's happening when we have one function, because this is a composition of functions. When we have one function, we have this situation where we have an input, we give it some input, and the function gives us some output. And remember that this input has to be part of the domain, and this output will end up being part of the range if it's a valid output. What's happening here, though, is not as clear. The innermost function g is applied first. So think of this first function as g. You give g an input, and it gives you an output. Now, but then that output becomes the input of f. Okay, so if this is f and this is g and this is the arrangement you have, g goes first, so the input goes into g, comes out as an output, but now that output becomes an input. I made a mess there. Becomes an input for f, and then f gives you its valid output, its range. So the things that we have to consider when we use composition of functions are that the outputs of g have to be valid inputs of f. And whenever we list the new domain, we cannot include values that used to make g invalid, even if f, for some reason, fixes that problem. And we're going to see an example of that in a minute. But just remember, this is what's going on. In a regular function, a regular just one f, you give it an input, it gives you an output. In a composition of functions, the innermost function goes first. You give it an input, it's going to give you an output. And then that output becomes the input for f, which then gives you a different output. And it looks a lot more complicated than it really is. We're about to see it in examples, and there's a couple of ways to do problems if you want. So we're going to see this in a more clear way. Let's begin with f of h of x, f(OH) of x, which is equal to f of h of x. And before we begin, let's look at our functions that were given, and let's figure out their domains. We know that 3x plus 1 is a line, so already I know it's all real numbers. I'm just going to put a little r because this is just to remind me that it's everything, all real numbers. The domain of g In a previous video, we talked about how to find the domain given a function or given the actual equation. Just as a reminder, the inside of the root cannot be negative. It can be 0 or anything greater. So in this case, the domain is going to be x is greater than or equal to 1. And for h of x, the domain is all real numbers. So we're just going to say all real numbers. And that's because it's a polynomial. So now let's take a look at f of h of x again. And they're asking us to plug in h of x into f of x. In this case, they're not asking us to evaluate for any number. They're just asking us to compose this function. So we're simply going to go ahead and say f of h of x is going to be f, so 3x plus 1. So it's going to be 3 something plugged in here plus 1. And that something that we're going to plug in is h of x, which is x squared plus 4. So let's go ahead and say x squared plus 4. And let's simplify. So we get 3x squared. 3 times 4 is 12 plus 1. And we finally end up getting 3x squared plus 13. And that's going to be our f of h of x. And so, since we know that h of x has domain all real numbers, we can say that this function has domain all real numbers. Furthermore, if I plug in any real number for h, or for x into h, I'm going to get a positive number, and that also works for f, so that's fine. So we're all good with f of h of x. Now let's take a look at h of g of x. H of g of x. So we're going to compose these two. Our innermost function is g, so we're going to start by writing it down. We're going to write down h first and plug in g, since they're not giving us any values to plug in. So we have h, so this becomes something squared plus 4. And then that something squared is x minus 1, or sorry, root x minus 1. So we have root x minus 1. And now let's go ahead and simplify. When we simplify, the square root of x minus 1 squared is going to be x minus 1. And we have plus 4. So this becomes x plus 3. But even though this looks like what it could be, which is a line, x plus 3 is a line. And in our minds, lines have domain all real numbers if they were just a regular line. But this is not a regular line. It's a composition of two functions, which means we have to take into consideration the domain of g. And the domain of g is that x is greater than or equal to 1. Therefore, this new function cannot take any values that are less than 1. And so we have to eliminate everything that's on the left-hand side of 1. And so if we were to graph this, we would graph it like this. And we would write that the domain of this function is going to be it's going to start at 1, and it's going to go all the way to infinity. So even though it's a line, and we know that lines are supposed to have domains all real numbers, in this case, it's not a function line, it's a composition of two functions. And that's why we have to take into consideration the domain of the innermost function. That is all for today's lesson. Thank you for stopping by. If you like the video, make sure to click like. If you want to see more content like this, make sure to subscribe. And if you have any questions, comments, concerns, or emotional outbursts, drop them in the comments below. Thank you.